Euler's formula. Let us study more about solid shapes, three-dimensional shapes. Activity. Observe the given two sets of figures. What is the difference between the figures of these two sets? Figures of set 1 are made up of polygonal regions only, and figures of the set 2 are made up of curved surfaces and polygonal faces. Activity. Observe the given solid figures of polyhedrons and complete the table. Here, V stands for number of vertices, F stands for number of faces, and E stands for number of edges. Number 1. In cuboid, it has 6 faces, 8 vertices, and 12 edges. Number 2. In triangular pyramid, it has 3 faces, 4 vertices, and 6 edges. Number 3. In triangular prism, it has 5 faces, 6 vertices, and 9 edges. Number 4. In pyramid with square base, it has 5 faces, 5 vertices, and 8 edges. Number 5. In prism with square base, it has 6 faces, 8 vertices, and 12 edges. Number 6. In pyramid with hexagonal base, it has 7 faces, 7 vertices, and 12 edges. Number 7. In prism with hexagonal base, it has 8 faces, 12 vertices, and 18 edges. The relationship between F, V, and E was first established by Euler, hence is referred as Euler's formula. Euler's formula is F plus V is equal to E plus 2, or F plus V minus E is equal to 2. Euler's formula is true for any polyhedron which is convex. Let's start exercise 6.3. Number 1. Which are polyhedrons from the following? Solution. Unsharpened pencil, tile, and diamond are polyhedrons. Nail and test tube are non-polyhedrons. Number 2. Using Euler's formula, find V if E is equal to 30, F is equal to 12. If the solid figure is a prism, then how many sides the base polygon has? Solution. It is given that edges is equal to 30 and faces is equal to 12. Thus, to find vertices, we use Euler's formula. V minus E plus F is equal to 2. Therefore, V is equal to 2 plus E minus F. By substituting the value of E and F, we get V is equal to 2 plus 30 minus 12. V is equal to 20. Since the given figure has 12 faces, if we remove the upper and lower faces, 10 faces remaining. Hence, the base has 10 sides. Note: Euler's formula is also applicable for two-dimensional figures of convex polygons. Example, for a pentagon, F is equal to 2, V is equal to 5, E is equal to 5. Therefore, F plus V minus E is equal to 2.